Assalamualaikum and good day to everyone. So I wish you safe. Do you know how many states of matter that we have? First, do you know what's the meaning of matter? Yep, matter is anything. Anything. Anything but not everything. Anything that have mass and occupy space. Your cat, your dog, your plants, your books, anything. But is rainbow matter? Do you think rainbow has mass and have volume? No, rainbow is just light. So rainbow doesn't have mass and does not occupy space. Therefore, rainbow is not matter. Alright, after we know that matter is anything that have mass and occupy space, then we go to the states of matter. Alright, states of matter. We have solid, liquid, and gas. And today we're going to learn about the difference between these three. What are the difference? Other than their what caused them to have the appearance like we see. Okay, we know that solid is something that it's hard, have fixed shape and volume. Liquid can flow and gas can diffuse. Right, so we're going to look at the difference between these three. Can differentiate according to the volume and space. Sorry, it's not space, rather it's the shape. The energy that the particle contains. This energy is more to kinetic energy. Kinetic energy. The arrangement, this one should be discussed first. The arrangement of the particles. Okay, so these are the aspects. This video is just for your understanding, but if you want to study for exam, you need to look up for the right term to get to write to have your answer accurate. So solid, liquid, and gas. Please bear with my handwriting and my unstraight lines. So we know that the arrangement of particles are very closely and very packed in solid. Okay, so we can say the arrangement of particles are very packed, ordered, and close. Particles are arranged close to each other, very close and very packed. Meanwhile, for liquid, the arrangement is still close but not packed. Close but not packed. Meanwhile, for gas, the particles are the building blocks of matter. Let's say, for example, your table. Your table is a solid form. It has particles inside, and the particles are closely arranged and packed. But for gas, they are not orderly and far away from each other. So the particles are far away from each other, and so it has random shape. Okay, we're going to look at the shape and volume next, because the particles are orderly packed and very close to each other. Can you guess whether the shape is fixed or not? Yup, the shape is fixed. How about the volume? Fixed volume. Liquid, okay, due to the arrangement that is close but not packed, so they if they can be transferred. Let's say, for example, we have this 10 ml of water. If we pour this water into an aquarium, a fish aquarium, the volume is still 10 ml. But now, is the shape fixed? Nope. So we can say that it has the fixed volume, but the shape, how can we say the shape? So liquid takes up the shape of the container. How about gas? Because gas, they are so random. If we fill a container with gas, the particles will fill all of the space of the container that they occupy. If this container is 20 ml volume, and then we transfer all of the gas in a bottle of 100 ml, because of gas, they are so free to move. They will occupy all of the space of the bottle. So, does the volume change now? Yes. Does the volume fixed? No. So it does not have fixed volume. So the volume is not fixed. And how about the shape? Of course, if you look at this container and this container, and the gas occupy all of the space, so the shape is also not fixed. So these are the difference in the aspect of volume and shape. So let's take a look on the kinetic energy. So if it is packed and very closely to each other, we can say that the particles cannot move. It can just vibrate on its place. Therefore, kinetic energy, which caused by movement, is very low for particles in solid. So we can write here low kinetic energy. How about the particles in liquid? So look at this arrangement. So these are close but not packed. The particles are moving freely compared to the particles in solid. So how can we say about the kinetic energy of the liquid particles? It's high. But how high? Higher than solid. If we look at the arrangement of gas, they are so far away from each other, so free to move. When they are free to move, they'll do more movement, so they will have more kinetic energy. So we can say the kinetic energy is very high. The kinetic energy of the particles are very high. Okay, we have another aspect. Between the particles, they are intermolecular force that hold the particle together. If the particles are very very close to each other, very packed in solid, what can we say about the intermolecular force? Yes, intermolecular force is very strong because they're very close. They can't easily break away from each other. How about the intermolecular force in liquid? So between the particles, because they are still close but not packed, we can say that the intermolecular force is weaker than solid. Meanwhile, if we look at the particles in gas, look, the kinetic energy is very high. They are very very freely to move around. So how about the intermolecular force between them? We can say the intermolecular force is very low compared to liquid. That's why they can overcome the force. Okay, like if you hold your friend, so your friend would not be able to move freely. But if you let go of your friends, you lose down a bit the force between you and friends, so they can move freely. Alright, that's all. I hope this give benefits to you. Thank you. Bye bye.